Okay, so we should know the formulas for the areas of certain shapes, like a rectangle, triangle, and a parallelogram. What I want to do in this video is have a look at some proofs to see if we can derive the formula for each shape. So let's have a look at a triangle first. Okay, so as you can see, we've got a rectangle here, and a rectangle has certain properties. We have equal sides, we have parallel sides, and as you can see, the diagonal splits the shape up into two congruent triangles. So I'm going to write that down. Congruent in maths is the same as identical. Okay, so we should know that the area of a rectangle, is the width multiplied by the length. Okay, so if the diagonal splits the rectangle up into two congruent triangles, and this is the width and this is the length, we can derive our area of a triangle. Is simply the width times the length divided by 2. Okay, so if we have a triangle, and we've got the height is B and the width is A, the area of our triangle is AB divided by 2. Okay, so let's have a look at another shape, a kite. Now, a kite has two pairs of equal sides. And the diagonals of a kite intersect at right angles, and they cut the kite up into two congruent triangles. Let's call this triangle 1 and triangle 2. They're equal. So let's have a look at the height of a triangle. Let's call the height X, and let's call the width Y. So the area of our kite is just simply going to be the area of triangle 1 plus the area of triangle 2. So let's find the area of triangle 1. The area of triangle 1 is going to be half of the base, which is going to be X, multiplied by the height Y, and we've got half of the height. The area of triangle 2 is going to be exactly the same. Half the base multiplied by the height, but we need to divide the height by 2. Okay, so we can start rewriting this. This is the same as xy all over 2. That is the same as xy all over 2. And don't forget, everything's divided by 2. So we've got fractions with the same denominator, so we can just add them to get 2xy all over 2. It's still all divided by 2. 2 divided by 2 goes once. So we get the area of a kite is xy divided by 2. Okay, so hopefully you can follow that. So why not pause the video and see if you can find the area of a parallelogram. Okay, so hopefully you've done that now. So let's have a look at the properties of a parallelogram. We have one set of parallel sides, two sets of parallel sides. If they are parallel, they must be equal. The diagonals of a parallelogram split the shape into two congruent triangles. Okay, so let me draw in the base and the height. Okay, so let's call the base A and let's call the height B. So we have triangle 1 and triangle 2. Okay, so the area then is going to be equal to triangle 1 plus triangle 2. Well, triangle 1 is half the base, which is A, multiplied by the height, which is H. Triangle 2 is going to be half the base, which is A, multiplied by the height, which is B. Okay, this height here is B. So let's add them together then. Half plus half is 1, so we got A, B. We should state that B is the perpendicular height. Okay, so perpendicular means at right angles. So if we were to drop a perpendicular line down here, that will cut at 90 degrees. Something a bit... Okay, that will cut at 90 degrees. Okay, so finally, we have a trapezium. See if you can pause the video and prove the area of a trapezium is half the height A plus B. So pause the video and see if you can do that. Okay, so hopefully you've done that now. So often when we have shapes like this, it's useful to split the shape up into rectangles and triangles. So let's call the height H. Let's call the length here A. And let's call these two lengths X and Y. Now let's be really clear here. And let's add some arrows in so that we can show what we're measuring here. So right to the end there. Okay, so we've got our various dimensions. So let's see if we can start finding the area of this shape. Okay, so let's call this area 1, area 2, area 3. So the area of this shape is going to be area 1 plus area 2 plus area 3. So area 1 is just going to be the formula for the area of a triangle, which is just the base multiplied by height divided by 2. So the formula of area 2 is going to be AH. And the formula of area 3 is going to be HY divided by 2. Okay, so let's define the entire length of the base here. Okay, so let's call the base here B. So we know that B is going to be equal to X plus A plus Y. So let's get a value of X plus Y, which is equal to B minus A. And we get that from subtracting A from both sides. Minus A, minus A. Okay, so let's do some factorization here. We can take out half H, and we just left with X here. We're going to have to do something a little bit fiddly here. If we take out half H, we don't have a half here, so we can insert 2A here. And if we multiply half H by 2A, we get AH. And we can take out a half H here to get Y. Okay, as you can see, we have X and Y here, which is the same as XY here. And if you can see, we want A and B in our formula. So let me rewrite that to show you. We've got X plus Y plus 2A. Okay, I'm now going to replace the XY with B minus A. So let's do that. Half H B minus A. And I've still got plus 2A. So let's move up here. So let's simplify then. Half H B, 2A minus A is just A, and then I'm left with my formula half H A plus B. Okay, I forgot to mention that the condition for trapezium is one set of parallel sides. Okay, so let's look at our final shape. Let's see if I can if we can rather find a formula for a sector. Okay, so a sector is something like this. This is our angle, theta, and we have a radius. Okay, so I'm going to tell you that the area of a sector is pi over 360 multiplied by pi r squared. Now pause the video and see if you can come up with this formula. Okay, so you should have done that now. So let's have a look how we come up with the area of a sector is equal to theta divided by 360 multiplied by pi r squared. Okay, so sector. Okay, so let's draw a sector. Okay, so let's turn this sector into a full circle with a radius of r. Now, the area of a full circle is just going to be 360 over 360 multiplied by pi r squared. 360 divided by 360 is just 1, so we just write it pi r squared. Now we have a fraction of 360. Remember, if we measure from there all the way around to there, we're going to get an angle of 360. Now we have a fraction of that. We don't know what the fraction is. We're going to call it theta 360. And we're going to multiply by pi r squared. Okay, so this isn't a formal proof. It's just showing how we derive a formula for an area of a sector. So I hope you enjoyed the video and carry on doing some maths. Thank you. Bye.